Welcome students. This is the first lecture of fluid mechanics. So fluid mechanics deals with the behavior of the fluids at rest as well as in motion. So the behavior of the fluids at rest is called as fluid statics, whereas the behavior of the fluids at motion is called as fluid dynamics. So what is a fluid? Any substance in the liquid or gas space is called as a fluid. So liquid or a gas space. So it is referred as a fluid. So what are the various properties of a fluid? So this we will discuss in detail. The first property is density. Density is defined as the ratio of mass by volume. So the unit of mass is kg and the unit of volume is meter cube. Therefore the unit of density is kg per meter cube. The density of water is 1000 kg per meter cube. So this you can write it in grams per centimeter cube also. So how you can write it? So 1 kg is equal to 1000 grams and 1 meter is equal to 100 centimeter. So when you take cube on both sides, you will be getting 1 meter cube is equal to 10 power 6 centimeter cube. So 1 kg per meter cube can be written as 1000 gram divided by 10 power 6 centimeter cube. So 1 kg per meter cube can be written as 10 power minus 3 grams per centimeter cube. So this is 1 kg per meter cube. So here the density of water is 1000 kg per meter cube. So this when written in terms of grams per centimeter cube is 1000 into, instead of this kg per meter cube you have to substitute 10 power minus 3 grams per centimeter cube. So this 10 power minus 3 and 1000 gets cancelled and you'll be getting 1 grams per centimeter cube. The second property, fluid property, is weight density. Specific weight or weight density. You can write it as specific weight or weight density. So it is denoted by small w. So specific weight is equal to weight per unit volume. The unit of weight is Newton and unit of volume is meter cube. So the unit of specific weight is Newton per meter cube. So the specific weight of water is 9810 Newton per meter cube. So how you arrived at this value. So this can be found out as follow. So specific weight is equal to weight per unit volume. So weight is equal to mass into acceleration divided by volume. This mass by volume again is density into, so this is the acceleration due to gravity. So the density of water is 1000 and acceleration due to gravity is 9.81. So when you multiply this, you'll be getting 9810 Newton per meter cube. The next property is specific volume. It is indicated by small v. Specific volume is the ratio of total volume to mass. So it is defined as a volume per unit mass. The unit of total volume is meter cube and the unit of mass is kg. Therefore you can say the unit of specific volume is meter cube per kg. Or you can write this as also as 1 by rho. Specific volume is equal to 1 by rho or 1 by density. The next property is specific gravity. It is denoted by capital S. Specific gravity is equal to specific weight of the liquid to the specific weight of the standard fluid. For water, for liquid it is water. If you are taking for the specific gravity of a gas, then the formula can be written as specific weight of the gas divided by the specific weight of a standard fluid. For gas, the standard fluid in the gaseous spaces air. So this specific gravity has no unit. The next property is viscosity. It is the property of a fluid which determines its resistance to shearing stresses. We know that the Newton's law of viscosity is given by tau proportional to du by dy. So this tau is the shear stress and this du by dy is the velocity gradient. So if you take a plate and if a fluid is flowing like this, at the contact surface the velocity will be 0. So at this point the velocity will be 0. So this velocity goes on increasing when we go away from the plate. So here the velocity is 0, and when you go in this opposite direction, the velocity increases. So here the velocity is 0 due to the reason that this plate is at rest. So the velocity changes in the vertical y direction. So this du by dy is called as the velocity gradient, and tau is the shear stress. So to remove the proportionality constant, you are putting a term mu du by dy. So this quantity is called as the coefficient of dynamic viscosity. Coefficient of dynamic viscosity. So this viscosity is due to the cohesion between the particles. So you can rewrite this equation as tau shear stress is defined as the ratio of force per unit area. So shear stress is equal to force per unit area. So this is equal to dynamic viscosity into du by dy. So to find the unit of dynamic viscosity, you have to bring the dynamic viscosity in the left hand side. So force per unit area divided by du by dy. So the unit of force is Newton and the unit of area is meter square. The unit of velocity is meter per second and the unit of distance is meter. So when you cancel all this, you will be getting Newton second per meter square. So the unit of dynamic viscosity is Newton second per meter square. So this is the SI unit. You can say it as Newton second per meter square or Pascal second, because Newton by meter square is Pascal. You can write it as Pascal second. In CGS system, the unit is poise. So 1 poise is equal to 1 dyne second per centimeter square. So this dyne is the unit of force in CGS system. The relation between this SI unit and CGS system is like this: 1 Newton second per meter square is equal to 10 poise. In MKS system, the unit of dynamic viscosity is written as kilogram force into second by meter square. So this, when converted to SI unit, it will give 1 kilogram force second by meter square is equal to 9.81 Newton second per meter square. So the next is, so this mu is the dynamic viscosity or the coefficient of dynamic viscosity. Next is the kinematic viscosity. It is denoted by nu. So dynamic, it is a ratio of dynamic viscosity and density. So kinematic viscosity is equal to dynamic viscosity divided by density. So the unit of kinematic viscosity is meter square per second in SI system. In CGS system, the unit of kinematic viscosity is centimeter square per second. So this is also called as Stoke. Thank you, students.